Hi, so I'm going to make a quick video today about how to, well, basically a little few tricks about the common trig values. So one of the things you need to know in GCSE and A-level maths, in fact, is some of these common values, some of these common trigonomic values. So, for example, sine 0 is 0, sine 30 is a half, and so on and so forth. So these are all the common trig values you need to know. 0, 30, 45, 60, and 90 for sine, cos, and tan. I've got the values here in terms of exact values, in terms of using square roots if necessary. And what I've done underneath is just rounded up if necessary to show the decimal values as well. So you need to know the absolute values. You don't need to know the decimal values, of course, but it's useful to know that to start to notice some patterns. You'll notice there are some patterns straight away. So, for example, root 2 over 2 is the same over here. So that means sine of 45 is the same as cos of 45. We'll understand why that is the case shortly. We can also see that sine of 60 is the same as cos of 30. And we'll understand why that is shortly in a moment too. And also that sine 30, which is a half, is the same as cos 30. And what else do we notice? We notice that, well, there's a few other observations, but they're, to be honest with you, a bit of a coincidence. The fact that, well, not entirely a coincidence. We'll look at a little bit more about why that is shortly. So let's start off by looking at a graph of sine theta or sine x and cos x. So the graph of sine x looks like this. So it has a peak, has its first peak at 90 degrees, and then it goes back down to 0 at 180. Now, we're only interested in from 0 to 90 anyway, so we only really need to look at this first bit of the graph anyway. So let's just draw a line there. Okay, so what I've done is I've taken that period of between 0 and 90, I've drawn a sort of shape here. And so we can see from this graph that, well, 0, sine of 0 is going to be 0. And you can see that if we draw a little line from here, we can see that that sine of sine of 90 is going to be 1. Over here, looking at this is cos x, then y equals cos x, and y equals sine x. So this is, so we can see that cos of 0 is 1. I can see cos of 90 is 0. And the reason why I divided them up into into three of the parts is that between 0 and 90, if you divided it equally, then at the first third mark here, this would be 30 degrees. The next one would be 60 degrees, and then obviously the final one would be 90 degrees. So we can follow this second line up, which would be 30 degrees, and draw a line here, and follow the second line up, which would be up here, and draw a line up there. So it looks like at the beginning, it starts to rise quite sharply, and then it starts to even off. Whereas on the other one, it starts to fall more slowly. So in other words, sine of 30 would be this value here, and sine of 60 would be this value here. Sorry, cos of 60, cos of 30, cos of 60. So we can see here that the halfway point, in fact, they've drawn the 0.5 on this point. We can see that from this graph that it looks like cos of 60 is equal to 0.5. And because it takes a while to fall to the halfway point because it starts to fall off more slowly, whereas the opposite happens with the sine graph. It rises very quickly to start off with, which means it gets to its halfway point within the first third. So sine of 30 equals 0.5. Likewise, you can see the second part is going to be so the second part starts to ease off more slowly. By the time it gets to sine 60, it's approaching the end near the end of 1. So we're going to, I don't know, guess about 0.7, I guess, and 0.7, 0.8 maybe, and it's going to be likewise over here, so about 0.7 ish, I guess, right? So we've got, so we'll look at the table in a moment. This isn't going to help you to prove the values. This is just going to a little bit of a reminder and help you to understand why certain patterns which we see in the table. Now, the halfway points, the sine 45, halfway between 0 and 90, will be right here between these two lines. And if you follow it up, no surprise, it's halfway up the curve. And because this curve is identical but slightly out of sync to the other curve, then the halfway point is going to be here. And we might be able to notice that because of these shapes are identical, that basically cos of 45 degrees is going to be equal to sine of 45 degrees. Okay, so we've got 30, 45, 60, and then we did 90, and we did 0. Just by looking at the graph, we've noticed a few things here. Now let's look at the table of identities that we've got to prove. I said that, so I said that the top bit was around about 0.7. This looks like it's a bit higher, obviously, 0.87, so around about 0.9 in fact. But the point is, it's past the halfway point. And I said that sine 45 is equal to cos 45, and as you can see, it is. I also said that cos 60 is equal to 0.5, and yeah, it is. And sine 30 is equal to 0.5, which you can see here. And we can also see the similarities that the greater value, which I wrongly predicted to be about 0.7, is sine 60, and that's the same as cos 60, so we can see that similarity there. I haven't looked at tan yet, so let's just look at tan for a moment. I've kind of, you can see a little glimpse of what I've been working at earlier on, but let's do it from the beginning. In fact, let me pause the video and I'll just set it up. So I've taken a triangle here, which I'll come back to in the later part of the video, with 60 and 30 degrees. So it doesn't really matter much about that triangle for now, but let's just take these trigonomic values of the trigonomic formulae. Sine theta is equal to opposite over hypotenuse. We could rearrange that to opposite is equal to 8 sine theta. Cos theta is equal to a over hypotenuse. Rearrange that to say that a is equal to 8 cos theta. And we know that tan theta is equal to opposite over adjacent, which means what we can do is we can say that tan theta is equal to 8 sine theta over 8 cos theta. And when you rearrange that, you can see that the h's cancel out, which means that tan theta is just equal to sine theta over cos theta. So let's go back to our table of values over here, and if tan theta is equal to sine over cos, then we're going to do 0 divided by 1, which is 0. Then we're going to do half divided by root 3 over 2. Now half divided by root 3 over 2 is the same as half times 2 over root 3. I won't go into how that is. Well, basically, all I did there is a divided by a over b divided by b divided by c over d is identical to a over b is equal to d over c. Sorry, a over b times d over c. So you can when you flip it upside down, it's the same as timesing. So dividing by a fraction is the same as timesing by the upside down version of the fraction. So what I did is I said that, so I'm doing tan 30 is equal to sine 30 over cos 30, which is equal to half divided by 3 over root 3 over 2, which is the same as half times 2 over root 3. And that's going to end up being 2 divided by 2 root 3. that ends up equaling 1 over root 3. Now, you might think, like, hang on a second, well, that's not root 3 over 3. Well, that's just because he's rearranged it to be a, a proper surd. We don't really like, when we're writing surds, we don't want to put the square root at the bottom. So we say that 1 over root 3 is, well, what we can do is we can times it by root 3 over root 3. Let me just change this ink a second. It's not very nice. Yeah, that's a bit of a nicer colour to be looking at, I think. So root 3, so basically if I multiply it by that, then we end up with root 3 over 3. And so that's what that one is there. Same over here. We've got root 2 over root 2. Well, these are identical, so when you divide them by each other, you're going to get 1. And then you've got, over here, you've got root 3. Now you've got the opposite. Basically, you've got the upside down version of this. Yes, this is the upside down version, because instead of dividing that by that, you're dividing, or instead of dividing that by that, you're dividing that by that, basically, aren't you? It's the opposite way around. So we already know that that is the same as 1 over root 3, so we can flip that and we have root 3. Okay, hope that was reasonably clear. Now this video is going to show a few different tricks, so that's part of it. There's some part of it. I don't want to just teach you some quick and easy ways to do it, although I will do that, but I also want to teach just the deeper sort of understanding of why lots of different patterns within this. That's one thing. Next thing I'm going to do is just teach you a really quick and easy trick, which I'm not going to really actually explain how it works, but it's going to really, if you just want a quick and easy tip of how can I remember these trig values, that's what I'm going to show you now. So this is the trick that a lot of you will probably find quite useful and may want to just, this might be the most popular part of the video. Perhaps I should have put this at the beginning. In any case, what you do is you'd simply, on the table, you write 0, 1, 2. In fact, I should probably write that quite a bit smaller. Let's zoom in a little bit. We're going to just write it quite small up here, I think. Whoops. 0, 1, 2, 3, 4. And then we're going to do the opposite with cos. 4, 3, 2, 1, 0. What I'm going to do with each one is I'm going to square root it, and then I'm going to divide it by 2. So I'm going to square root each one, and then I'm going to divide by 2. So square root of 0 so square root of 0, square root of 1, square root of 2, square root of 3, square root of 4. Okay, and then I'm going to divide by 2 with each one. So I'll divide by 2 for each one now and square rooted it. So now we're just going to work it out. Square root of 0 is 0, divided by 2 is obviously 0. Square root of 1 is 1, divided by 2 is so half. Square root of 2 divided by 2, well, that leaves it as it is. Square root of 3 divided by 2, well, that can't be simplified. Square root of 4 is 2, divided by 2 is 1. Square root of 4 is answer again the same. It's going to be 1. Square root of 3, well, that one's already done. That one's already done, so we can see these two are the same. Square root of 1 divided by 2 is, well, it's going to be equal to half, and that's equal to 0. Then we know that tan is equal to sine over cos. 0 divided by 1 is 0. Half divided by root 3 over 2. Well, we did this one just a moment ago, didn't we? So we've already solved these problems. So we already did how to work out tan in the earlier part of the video. And then the last bit where it says undefined, well, 1 divided by 0 is undefined. Some people call this infinity. We're going to leave it as undefined. Okay, you can't do it. If you do it on a calculator, do anything divided by 0 on your calculator, you'll get a math error. Basically, it means there is no value of tan 0. If you do the graph of tan theta, it never reaches 90. Okay, so that's a really, really useful little trick, and some of you may have, some of you may want to switch off at this point. But what I would like to do now is prove it. Those of you, especially if you're doing A-level maths, or you're thinking about doing A-level maths, or you're trying to push those grades, then keep listening to this next part, and we're going to go ahead and try to prove why these values are the case. This is not really proving anything. This is just a trick, like a magic trick, to help you to remember it. But the next part is going to show why sine 30 equals whatever it equals, and so on and so forth. Okay, so that's what I'm going to do next. Okay, so what I've got here is a right-angled triangle, not a right-angled triangle, equilateral triangle, and as we know, equilateral triangles have angles of 60 degrees. Let's pick a different color. And so let's label that angle 60 degrees for now. They're all 60 degrees, of course, but we're just going to label that one for now, and it will become apparent why shortly. We're going to imagine this triangle has sides 2. I can make it obviously whatever sides I want. They're all going to be equal, and the angles will be 60 degrees. Now, what we're going to do next is we're going to chop it directly down the middle. Oops. Well, we're going to try to chop it directly down the middle. And if I did, then this is now a right angle. And over here, this is going to be a value of 1. Oops, let's delete that. And we're going to sort of forget about the other part of the triangle. Now, because all angles in a triangle, we're just looking at this this right-hand side now. So I've just coloured in the right-hand side so we know which part of what we're looking at now. And all angles in a triangle add up to 180. So we've got 60, we've got 90. The remaining angle will be 30 degrees. Okay, so that's quite useful because, well, we know we're looking for 30 and 60, right? So let's see if we can work out the values for cos 30 and 60. So let's have a look. The first thing we're going to do, we're going to use Pythagoras. We're not going to prove the Pythagoras equation here. We're just going to use it. So remember that a squared is equal to b squared. Again, a squared plus b squared is equal to c squared. So c represents the hypotenuse in this case. So we're saying that basically, and this is going to be the mystery side. So it could be a, for example. So a, so basically this missing side here, we're going to just call it a, I guess. A squared is plus 1 squared is equal to 2 squared. So a quick rearrangement, a is going to be equal to the square root of, well, that's going to be 4, take away the 3, sorry, take away the 1, it's going to be the square root of 3. So next what we're going to do is, let's just get rid of that then for now. Next what we're going to do is going to use these trigonomic values, and we're going to say let's start off with theta is equal to 60 degrees, and we'll say that, well, we know that sine theta is equal to opposite over hypotenuse, so therefore sine 60 must equal to the opposite, which would be root 3, over the hypotenuse, which is 2. And if you look at the table of values, you'll find that's the case. There we can see sine 60 is equal to root 3 over 2. Let's do cos 60. What would cos 60 equal to if theta is equal to 60? So cos 60 is equal to adjacent over hypotenuse. So that would be 1 over 2. And if you look at the table, that is the case. Now let's say theta is equal to 30 degrees. Well, sine 30 is going to equal to opposite over hypotenuse, which is the opposite would be 1. The hypotenuse would be 2. Sine this time, cos 30 is equal to adjacent over hypotenuse. The adjacent is root 3. And the hypotenuse is 2. So there we go. We've got the values for cos theta, cos and sine 30 and 60. Now let's have a look for the value for a 45 degree triangle then. So this one's a little bit simpler to do because you don't have to do that first step with the equilateral triangle. So let's just start off with a 45 degree triangle. Okay, so we've got a 45 degree triangle here. Now, a 45 degree triangle is going to have 2 45s either side of it. That might give some of you a glimpse as to how I'm going to do the next bit. I'm going to say that this side is, let's use a darker color again. In fact, let's just write it on here. This side is 1 degree. On this side over here is 1 centimeter or whatever it is. The length is 1. And then we're going to say, well, that's the hypotenuse. So that side there, I will choose a darker one then. We're going to just call it C using the Pythagoras. And we know that A squared plus B squared is equal to C squared. And so quick bit of rearrangement, you're going to do 1 squared plus 1 squared, rearrange it, and therefore C will be equal to the square root of 2. So let's rewrite that. Square root of 2. Okay, so we've got our triangle now. We know the lengths of our different sides. So let's move that up there, change its color. And we'll now go ahead and try to prove these different cos and sine. Remember, we're not going to bother proving tan because tan, as I said before, I showed earlier on in the video, is just sine theta over cos theta, and so you can do that afterwards. But we're just going to do the 45s, and as you can see, they're going to be the same. Now, because of the earlier part, some of you might have already been able to jump ahead and realize that they're going to be the same because these two angles are the same. But let's go through the steps anyway so we can see it nice and clearly. So cos, I'm going to choose a different color again. So cos 45 is equal to adjacent over hypotenuse, which is 1 over root 2. And you can rearrange that. So 1 over root 2, well, let's times it by root 2 over root 2, which is just 1. The bottoms end up being just 2, and the top ends up being root 2. Okay, and now it looks like that. But either one of those are correct, but that one there is how you would draw it, write it as a third. Let's do sine 45. Sine 45 degrees, this is. Then we're going to do is opposite over hypotenuse. So it's going to be 1 over root 2 again. And we already know that that's root 2 over root 2. So what have I proved? I proved that I proved sine 30, sine 45, cos 6, sine 60. I did all those. Technically, I've already done those already because I showed that tan is equal to sine over cos. I haven't done these apart from looking at the graph. So I'm just going to leave that there, to be honest with you. I think we just need to know that, remember that the graph starts at 1 and starts at 0, and then we can see that's the case. So I hope that was useful, and it was quite extensive, and I think depending on what you want to get out of it, depending on how far you want to go with maths, then you're going to find different parts of it useful. But please do share it, and if you're interested in online tuition or more videos, do let me know. Thanks. Bye.